The yield curve for default-free zero-coupon bonds is currently as follows. At 1 year maturity, 10.2%, 2 year, 11.2, 3 years, 12.2. What are the implied 1 year forward rates? We're going to go to our template and go to forward rate calculations. Let's go implied 1 year forward rates. So our short term is 1 year, long term is 2 year, so forward term is 1 year. Frequency is 1 because this annual compounding. Short-term yield is 10.2, long-term yield is 11.2. And to make the cost of borrowing at the forward versus long-term, we make the difference 0. Data, what if analysis, goal seek, 0 by changing the forward rate. So the 1 year rate is 12.2091. Find the 1 year forward rate 2 years from now. We make the short term 2, long term 3. Do another goal seek on that difference. Data, what if analysis, goal seek, 0 by changing the forward rate. So forward rates 1 year, 2 years from 1 year forward rate 2 years from now is 1323, rounded to 2 digits. Let's go to part B of the problem. Assume that pure expectations hypothesis of the term structure is correct, which means future rates are going to be exactly what the rates implied by the forward curve. What will the pure yield curve be next year? Well, those are going to be, let's calculate first the 1 year rate, which we did, but let's redo it. So let's calculate the 1 year rate, 1 year into the future. Data, what if analysis, goal seek, make the difference 0 by changing that. Oh, by changing, let's do that first. By changing the forward rate. So next year, the 1 year rate is going to be 12.2091%. And the 2 year rate, now short term is still 1, but long term is 2, 3. So the forward rate is 2 for 2 years. Data, what if analysis, goal seek to 0 by changing the forward rate. So 2 year rate, 1 year from now is expected to be 1170. Let's go to part C. If you purchase a 2 year zero coupon bond now, what is the expected total rate of return over the next year? Okay. Now, that means I'm going to calculate the price of the bond now. It pays no coupons. And I'm going to calculate the expected price of the bond 1 year from now. First, let's go to our bond pricing. Currently, face value, let's say 1,000. Years to maturity is 2. So if I buy and yield to maturity is 11.2, because currently 2-year bonds are trading at a yield to maturity of 11.2. So that is the current price. Let's copy that, paste it here. 1 year from now, this bond will have only 1 year left to maturity, but the 1 year rate is no longer 10.2. If the expectations hypothesis is correct, we should expect the 1 year rates to be 12.21. And that bond is going to be trading at that level. So let's take the price, then divided by price now minus 1. Convert that into percentages. So 10.21, 20% is the expected rate of return. Part D asks a similar question, which is if you purchase a 3-year zero coupon bond now, what is the expected total rate of return over the next year? Well, we're going to do similar calculations. Currently, the yield to maturity of 3-year bonds are 12.20. Okay. So they would be trading at 707.98. Next year, this will have 2 years left to maturity, but the 2-year rate is going to be 11.70. And that is, oh, I made a small error. Let's go back. 3-year bond, 12.2. Okay, that's the price. I just realized that I made a mistake in my forward rate calculations when I was doing this 2-year rate, 1 year forward. I used the wrong long-term rate. Should have been 12.2. So let's redo it. Data, what if analysis, goal seek to 0 by changing the forward rate. So 1 year from now, we should expect the 2-year rates to be 13.2136. And going back to our bond pricing, oh, 2 years left, and 10.20%. That is actually what's behind the expectations theory. Whether you buy a 1-year bond now, 2-year bond, 3-year bond, if expectations theory is correct or expectations hypothesis is correct, uh, all bonds will have the same expected rate of return. Why? Because future rates of return or future yield curve is going to be determined exactly by the forward curve.